The difference quotient. Okay, this is a really cool thing. We use this a lot in calculus if you'd be going on to that course. It is used to approximate a lot of things. For us, we're just going to kind of see it as an application of adding and subtracting functions. Okay, what it is we have these 2 points. First of all, x and x plus h. So somewhere further past x, right? We don't know how far it's going to be h. And then I determine what the function value is at each of those x values. So we get x and f of x, and x plus h and f of x plus h, whatever that corresponding y value is. And if I join those two with a straight line, we call that a secant line because it crosses this curve in 2 spots and cuts an arc off of it. The interesting thing that happens is if we move this point closer and closer so that we reduce the size of h, we let it get close to 0, what we end up approximating is the tangent line here. And so the slope of the secant line will eventually become, if we let h get small enough, the slope of the tangent line. And that, like I said, has a lot of applications in calculus where we are finding marginal costs, marginal revenues. We're going from a distance function and finding a velocity or an acceleration. So it's really a useful thing. All right, let's look at an example of how we would calculate this. Finding the difference quotient if f of x is equal to 4x minus 1. Right? This is our formula. They're going to tell me this. F of x plus h minus f of x all divided by my h. Okay, so I take f of x plus h. What does that mean? It means I plug x plus h, whatever's in this parenthesis here, I plug that in for the x. So I erase this x that's originally in here, and I put in the x plus h instead. So 4 times the quantity x plus h minus 1. Now note, I put brackets here to indicate, okay, that's the first part, minus some more brackets for whatever this is. Well, this is simply f of x. I don't even have to calculate anything. I just copy whatever they told me f of x was. And then it's always all going to be divided by h. Go ahead, distribute, clean up your parentheses here, get rid of those, and you will realize, wait a minute, when I multiply this all out, I can cancel some things, and I end up with 4h over h, which is simply a 4. Now, like I said, it's the slope of a secant line. If this is originally a linear function, then it's going to end up just being the slope of the line, and we know that would be 4. Let's look at one that's a little bit more involved. What if we want to find the difference quotient for a parabola, quadratic, 3 minus x squared? Okay, well here is our formula, f of x plus h minus f of x all over h. The only calculating part we have to do is this f of x plus h. And what that means is, again, I take the x plus h here, I erase the x that's originally in f of x, and I put x plus h there instead. Okay, so 3 minus that quantity, x plus h squared, minus whatever f of x is, so in brackets, make sure you include the brackets, 3 minus the x squared over our h. Now what about this x plus h quantity squared? How do I get these 3 terms here? Why isn't it just x squared plus h squared? Well, remember, when you square something, it really means multiply it by itself. So x plus h times x plus h, if you FOIL it out, you will get these 3 terms here. And then I have to know that I'm subtracting that, so it's actually going to be 3 minus the x squared minus the 2xh minus the h squared, and then over here we distributed our minus sign to that last part and got minus 3 plus an x squared. Some things cancel out and we get negative 2x minus h as our answer.